Well, hello. This is yet another exciting episode of Fun with R. So, right here you can see I've opened up an R window, and what I'm going to do is enter data in a few different ways. So let's suppose we have a small set of numbers. The simplest way is you think of any data name. So I could call it my data, I could call it X, anything else. The simplest way is to use concatenate, where you can just type in values. If you want to see what values you've saved, you go like that. You can actually even do categorical values. So a variable that's categorical, let's say treatment 1 in quotes, treatment 1, treatment 1, treatment 1, treatment 2, treatment 2. So words in general, characters get to be put in quotes. In fact, if I look at the type, there's actually a variable class or a function class that shows you, see, the numbers I put in right here are all numeric. I can always look at them just by typing the name, whereas the class of mydat or my cat for categorical is character, because my cat is all categorical variables. So be careful. Sometimes you want to enter names, things that aren't numbers, and the way to do that is as a categorical variable. You can also put missing. Let's say one of your data actually is missing. 1, 2, 5, 4. But let's say the next one is missing. The default missing in R is NA. 8, 7. So let's see. It's still numeric, but it has a missing value in it. So you can always insert missing values into variables. What next? Sorry. That's one way to put data in. Another way is using the scan command. Now, you can put data in one variable at a time using scan. So let's say we have a variable X, and we want to create it. If we just say scan, you're allowed to put numbers in any way you want. You can put them on the same line. So this is really good for cut and paste. You can cut out of a document, drop it in here, and you keep going, and then you just hit return. We'll look at X, and there you have your variables in there. Let's do mean of X, standard deviation of X, variance of X. All those are easy computations. You actually can read multiple columns in using scan, and this is really good for cut and paste. So watch this. But use a command equals what? Now this is weird. So for every column you're going to put in, you have to put something in this list. If a column is numeric, I'm going to put a 0. And if it's a character, I put quotes. So what I'm going to do is, this is actually, I'm going to put in 3 variables. And the first one's numeric, second one's a character variable, and the third one's a numeric. So this is like if I'm cutting and pasting out of a data set. So 1, high, 2, 2, high, 3, 4. How's that? 1, low, 5, 2, low, 6. I'll hit return. Has 4 records. If I look at what X is, you'll notice it does this weird thing. It puts it into something called the list. So X of 1 is the first variable, X of 2 is the second variable, and X of 3 is the third variable. So after I paste these in, I can actually break out each one. So I could say, let's say, sample number. Let's say the first one is sample number. I can make that X of 1. I can make level equals x of 2, and I can make, I don't know, nitrogen x of 3, and I've now, from that data set, I've split out the 3 variables. So let's look at what sample number is. There it is. Level's that, and nitrogen is that. Okay, so that's 2 ways. The scan is especially good, like I said, if you're cutting something out of a document and pasting it into R. Another method, and this really only works well if everything is numeric, but if you have several columns that are numeric, here's another way you can read them in. So let's say I have 3 numeric columns, say nitrogen, phosphorus, and pH. I can do this. I can say dat equals matrix. And what that's going to do is read in a matrix of data. And I'll say n columns equals 3, because I'm going to have 3 columns. I will have by row equals true, because I'm going to put them 1 row at a time. And then you say scan. And what that'll do is it'll allow you to put in the 3 columns 1 row at a time. So let's say I have nitrogen first. So I'll go 100, phosphorus 100, pH 8.0, and I have another 100, 8.2. So I have 120, 120, 8.2. Let's say I have another 120, but a 100 and 8.4. Okay, read 12 items. If I look at that, this is essentially a matrix of values. So that's the nitrogen, phosphorus, and pH values. So especially if I have 3 columns, I can just cut and paste right in here. That's a really nice way to make put columns of data in. Let's say I've done that, and then I want to break out the different columns. I could do nitrogen is the first column. Here's how I get the first column. I say dat, and then I put the rows first. It's all the rows, so I just put a comma, and then I say column 1. Phosphorus is, guess what, column 2, and pH is column 3. Now if I look at those, there they are. Okay. So what have we done so far? We've seen 3 ways to put things in. You can put them in using concatenate and creating variables 1 at a time, including all of these. You can put a missing value in there anytime you have a missing one. You can use scan, which can read either one variable, and it doesn't matter if you put 1 in each line or if you put a lot of them. As long as they're separated by spaces, I can type data in here. I could put it all in one long line if I wanted to, but that created X. Using scan, scan can create multiple variables, even a mix of numerical variables and categorical variables, like I did there. Notice the categorical variable is all with quotes around it. And I can break those out 1 at a time if I want. And then another method is to use matrix. That's if I'm cutting and pasting 3, let's say 3 columns all at once. But with matrix, if you're going to use matrix, you don't forget to use by row equals true. So it says this is the first row, second row, so on. And they should all be numeric. You should, if you're going to use the matrix approach, you shouldn't have a categorical variable. And so you get a matrix here, and if you really want to, you can peel off each column of the matrix, first, second, and third, and rename them as variables. Okay. Well, those are 3 ways to get data in. What's another way? Well, let's look at something we've all seen, Excel spreadsheets. So sometimes data comes in the form of Excel. What you could do with Excel is, where is that? Is save it. See what it opens up here. We're going to save it, I don't know. Let's say it's soil data. And we'll save it down here as a CSV file. So, that's way down here. You can't see it. I'm going to comma separated file .csv. Okay. So, I'm going to save. Let me make sure. And where will I put? I'll make sure it's on the desktop here. Why not? Okay, so I'll save that, and it'll put this out and save it as a CSV file. Let me get rid of this and hunt for that file. Where is it? No, that's not it. Where is the CSV file? I put it somewhere on here. Should be. Here we go. It's right there, soil data CSV. If I open that, it's going to open it as Excel file. I don't really want that, but watch what we do in R. So when it's been saved as comma separated variables, we can actually get to it. And what we do, we need to find its file name. So I'm going to say file choose. And what that's going to do is open a menu where I can find that file. There it is. Let's look. We can see there is the file name. So I can do the command read CSV. And there it is. So it has my 3 columns of data from that file. Automatically puts the variable name based on the header. We've got everything there. The class of this is actually a data frame, I think. Let's see. Yep, it sure is. So that means you can get each part of it out this way. If I want the first one, I go sample number. There's the first column. Out. So getting parts of data frames, I can get the pH, and I can get nitrogen. Okay, so those are 3 ways to get data. So you can extract them also from Excel spreadsheets using CSV files. Okay. Let's do a couple simple calculations now that I've actually done this. So let's say we have a population of size 220. So I'm taking a completely different turn here. Sorry. Or 400 samples possible. And we've actually looked at only 10 of them. And we get this as a data set. So why not use scan? I'll use scan. There's many ways to read data in. But so let's say I see 12 items in the first sample, 15 in the second sampling unit, 10 in the third, 10 in the fourth, 10 in the fifth, 11 in the sixth, 12 in the seventh, 18 in the eighth, 19 in the ninth, and 22 in the 10th. Okay, let's look at that data. There it is. By the way, if I make a mistake and go, ooh, that third one's 10, it should have been 15. I can always do this, which is really nice. Oops. Edit x equals edit x. And what that'll do is open up a little thing, and I can even edit spreadsheets. I'll show you in a second, but with just a single variable, I can change and go, that third one should have been 15. Oops. You hit that, you say save. Now look it. It's been edited so that the third one is 15. There's actually another way to fix that. So let's say I go, third one shouldn't have been 15, it should have been 13. A separate way to fix that is say, okay, the third thing in X should be 13, so I'll do that. Now I look at X, I fixed it that way. So edit will fix it, or you can use indexing to fix a particular value. So, okay. Now what? Oh, yes, I was saying. So we have, out of 400, we have a sample size 10. Here's our actual values. We fix them. By the way, just to see it, but I'm not gonna change anything. Remember that way back when we saved a matrix? What did we call it? Oh, let's look at the data frame we saved out. I think that'll work. You can actually, if you have an object with multiple columns, you can fix some of them even. So right here I could go, that really shouldn't have been 8.2. It should have been 8.3. And there it is. It's fixed at 8.3. Notice I edited, but I didn't save the output. So let's look at what happened earlier. Oh, here when we saved the output, I said x equals edit x. Here when I just said edit out, I fixed it, but it's not been saved because I didn't tell it to store the output of this in out. So edit is great. Let us jump back. So we're back here where I've taken, out of a population of 400, I've taken 10. Here's my data. How do I numerically calculate a confidence interval? Well, the mean of x is a good center for it. And the standard error is the square root of, here's our fraction, you probably are sick of this one, n minus n over n times s squared, which is variance of the x over n. So that's just our variance formula. Taking the square root makes the standard error. Oops, what happened here? Oh, sorry. Here, let's see. I'm missing a parenthesis. Okay, there we go. Let's see, we've got our finite population correction right there. We have that. Okay, good. There's our standard error. So our confidence interval is actually going to be the mean of x minus the 2 times the standard error, all the way to the mean of x plus 2 times the standard error. That's for simple random sampling with replacement. Okay. What happens if we go, n equals 10 seems a little bit small. And look at that population. That is not a normal looking sample by any means. Okay, I just did a histogram. So I might want to do a bootstrap. So I'm going to show an example of bootstrapping the mean. So I could have got a confidence interval for the mean, 11.6 to 16.8, roughly. Let me see. If I'm going to bootstrap, remember I have to sample from my sample lots of times. So I'm going to sample 1,000 times from my sample. So I'm going to say resampled means I'm going to put a NA, which is missing, and 1,000 of them. The command head and tail looks at the top or the bottom of a variable. So, oops, resample. Oh, resampled, sorry. Okay. Notice the first few variables or values in here are missing. It's really a gigantic, I've just created a long variable with 1,000 missing values. I'm going to fill that with my resampled means. So here's how I do it. For I in 1 to 1,000, put a bracket. Now it's going to loop 1,000 times. And each time what I want to do is take a sample. So I'm going to take a sample from X. That's my original sample. It's going to be of size 10. Okay. If I have 10 things and take a sample of size 10 from them, I better replace each time I draw one out, because otherwise I'll get the exact same sample each time. Okay, so that's my sample. Now what I'm going to do is I'm going to compute the mean and save it in that resampled means. So I go like that. I'm going to take the mean of Sam. Notice I can do the median, all sorts of other stats just as easily. Okay, and I stop right there. It ran almost instantly. Let's look at the head of resampled means now. Okay, I have a bunch of values. So I can look at the histogram of those. Notice how reasonably bell-shaped this is. So it actually looks like central limit theorem's kicking in. Okay, so what I need to do is get the middle 95% of those. So I'll use the command quantile. The lowest 2.5% is 11.9. The upper 2.5% is 16.8. So that means bootstrap confidence interval, 95% confidence interval, is 11.9 to 16.8. So how does that compare with the one we got by just the normality based formula? 11.6 to 16.7, 9. They're actually amazingly similar. So in this case, bootstrapping wasn't quite worth it. Okay, so I will stop now. What have we done? Let's look back here. We have seen how to read in a variable in a really simple way, one or more variables. We've seen how to use scan to read in variables. This is alternative. We've seen how to read variables in as a matrix, which is really scan again. We have seen how to read data from a CSV file, which we can get from Excel. And we can look at each separate variable from that if we want. And given some data like population size, sample size, and some data, I've shown how to both type in the, I guess you'd call it central limit theorem based formula to get the confidence interval, and then a bootstrap based approach to get the confidence interval. And I think I'll quit now. Okay.